Ever pondered on how our Earth compares to Mars, the red planet? Today we're going to dive into a fascinating comparison between these two celestial bodies. Understanding these planets is not just a matter of scientific curiosity, it also holds the key to answering some of our most profound questions about the universe and our place within it. Earth, our home, is a vibrant blue dot teeming with life, while Mars, our neighboring planet, bears the nickname the Red Planet for its iron-rich surface. But how do they stack up against each other in terms of size, geological features, atmosphere, and potential for life? In this video, we'll delve into a detailed comparison of Earth and Mars, drawing on the latest research and discoveries. We'll explore their physical characteristics, atmospheric conditions, geological features, and the intriguing question of potential life on Mars. Brace yourself for an enlightening journey through the cosmos as we compare and contrast Earth and Mars. Starting off with their physical characteristics, these two planets have some striking differences. Let's begin with size, one of the most noticeable differences between Earth and Mars. Mars, often called the Red Planet, is only about half the size of Earth. If Earth were the size of a basketball, Mars would be more equivalent to a softball. However, don't let that smaller size fool you. Mars is not to be underestimated. While it is roughly half the size of our home planet, it has nearly the same amount of dry land. This is because our Earth is covered by about 70% water, unlike Mars, which has very little surface water. Now let's talk about mass. Earth is significantly more massive than Mars. The mass of our planet is approximately 10 times that of Mars. This difference in mass leads to a stronger gravitational pull on Earth, something we all experience every day. As for composition, both planets are rocky, but that's where the similarities end. Earth, as we all know, has a diverse array of elements with oxygen, silicon, and aluminium making up the bulk of its crust. Mars, on the other hand, is made up mostly of iron, magnesium, and silicon. This iron gives Mars its characteristic red color, a stark contrast to the blue and green hues we associate with Earth. Also worth noting is the fact that Mars has the highest volcano and the deepest, longest canyon in the solar system. Olympus Mons, the volcano, is nearly 3 times the height of Mount Everest, the tallest peak on Earth, and Valles Marineris, the canyon, is as long as the United States is wide. While Earth and Mars might not be twins in terms of size, they do share some interesting similarities in their physical features. For instance, both have polar ice caps, and both have had volcanic activity. So, despite their differences, there's a certain kind of kinship between our blue planet and the distant red one. Diving into the atmospheres and climates of these two planets, there's much to be uncovered. First up, Earth. The atmosphere of our home planet is a cocktail of nitrogen and oxygen, with a pinch of argon, carbon dioxide, and trace amounts of other gases. This mix is crucial for life as we know it, providing the oxygen we breathe and trapping heat to keep our planet hospitable. The climate, governed by this atmosphere, varies widely, from the icy poles to the scorching equator, with a dazzling array of weather patterns in between. Rain, snow, wind, and sunshine, they all play their parts in the grand performance that is Earth's climate. Now let's jet over to our rusty neighbor Mars. Mars's atmosphere is thin, very thin. In fact, it's less than 1% as dense as Earth's. This Martian atmosphere is predominantly carbon dioxide, with smidgens of nitrogen and argon. This thin atmosphere doesn't trap heat very well, resulting in a much colder planet. In fact, the average temperature on Mars is a frigid negative 80 degrees Fahrenheit. Brrr. The weather on Mars is a different beast altogether. Dust storms are the norm, not the exception. These storms can engulf the entire planet, lasting for weeks or even months. And let's not forget about the polar ice caps. Yes, Mars has them too, just like Earth. But these are made of frozen carbon dioxide, or what we commonly call dry ice. So, while Mars may bear some superficial similarities to Earth, like polar ice caps and dust storms akin to our hurricanes, their atmospheres and climates are worlds apart. The thin, carbon dioxide-rich atmosphere of Mars creates a cold, dry, and harsh environment, a stark contrast to the warm, wet, and life-friendly climate of Earth. The atmospheres and climates of Earth and Mars are as different as night and day, each unique in its own right. Let's delve into the geological features of Earth and Mars, a topic that reveals some fascinating contrasts and comparisons. Our home planet, Earth, is a vibrant world filled with diverse geological features. It's a living planet, constantly changing and evolving. From the highest peaks of the Himalayas, standing tall at nearly 5.5 miles high, to the Mariana Trench, the deepest part of our world's oceans, plunging down more than 7 miles, Earth's landscapes are incredibly varied. Our mountains are formed by the action of tectonic plates. When these plates collide, the land buckles and pushes upwards, creating these majestic landforms. Valleys, on the other hand, are often carved by the relentless flow of rivers eroding the land over millions of years. Now let's transport ourselves to Mars, the red planet. Mars too is home to a variety of geological features. But, unlike Earth, Mars is a silent planet. Its core cooled down billions of years ago, halting plate tectonics. Yet it has the highest mountain and the deepest, longest valley in the entire solar system. Olympus Mons, a shield volcano, is an impressive 3 times the height of Mount Everest. And the vast Valles Marineris, a system of canyons, stretches over 2,500 miles long, making it nearly 10 times the length of our Grand Canyon. These features were formed by volcanic activity and the stretching and cracking of Mars' crust. There's also evidence of ancient river valleys and lake beds on Mars, suggesting that water once flowed on its surface. This is a tantalizing clue to the planet's past, and a hint at how similar Mars might once have been to our own blue planet. From towering peaks to sprawling valleys, both Earth and Mars boast incredibly diverse landscapes. Whether we're gazing at the rolling hills and deep oceans of Earth or marveling at the towering volcanoes and vast canyons of Mars, it's clear that our solar system is home to a stunning array of geological wonders. Perhaps the most intriguing question of all: is there potential for life on Mars as we know it on Earth? Diving right into it, when we talk about life, we often think of organisms as complex as ourselves or as simple as single-celled bacteria. Earth, our home planet, is teeming with life. It's a bustling carnival of biodiversity, from the deepest oceans to the highest mountains, from the hottest deserts to the coldest tundra. The conditions on Earth, with its warm sun, abundant water, and protective atmosphere, have made it an ideal cradle for life. On the other hand, Mars, our red neighbor, is a stark contrast. Its thin atmosphere, chilly temperatures, and lack of liquid water on the surface present significant challenges for life as we know it. But don't let that discourage you. The key word here is as we know it. Life on Mars, if it exists, might be different from anything we've ever encountered. In the past, scientists have found tantalizing clues that suggest Mars might have once harbored life. Features resembling dried-up riverbeds and minerals that form in the presence of water have been spotted. This indicates that Mars was once a much warmer and wetter place, potentially suitable for life. Moreover, recent discoveries have added fuel to the fire of speculation. Scientists have detected traces of methane in the Martian atmosphere, a gas often produced by living organisms here on Earth. While the source of this methane is still unknown, it's a promising sign that life, in some form, might exist or have existed on Mars. And let's not forget about the Perseverance rover, digging away on Mars as we speak, in search of signs of ancient microbial life. Its mission, and the missions that will follow, will take us one step closer to answering the age-old question, are we alone in the universe? Although Mars may not teem with life like Earth, the quest to discover life beyond our planet continues. To wrap it all up, Earth and Mars, while being neighbors in the solar system, are worlds apart in many ways. We've journeyed through the physical characteristics of both, noting Earth's lush blue and green, in stark contrast to Mars's reddish-brown. We've explored their atmospheres, with Earth's life-sustaining mix of oxygen and nitrogen, and Mars's thin, carbon dioxide-filled air. We've examined their climates, Earth's being varied and dynamic, Mars being cold and arid. We've looked into the geological features, Earth's diverse landscapes against Mars' vast plains and towering volcanoes. And we've pondered the potential for life, with Earth teeming with biodiversity, and Mars, a question mark, a puzzle scientists are eager to solve. While Earth is our home, Mars represents a tantalizing mystery and a potential future destination for mankind. Until then, we continue to explore, learn, and marvel at these two fascinating planets.